Today we shall be discussing the concept of modeling in engineering mathematics. As I used to say, before you can model successfully, you need to be aware of the physical law guiding the process. Also, you need to be able to express the law mathematically, and then you have to be able to solve the model and be able to interpret the model. Let's look quickly at a simple case. The question goes, they are given an amount of 1 gram of a radioactive substance. Find the amount present at any later time. Now, this is a simple process. It's radioactive, and we know it's radioactive, and we know the law guiding radioactive substance, which is that the rate of change, if the amount of radioactive substance is y, then the rate of change of y is proportional. That is, the y dt is proportional to the amount of y present at that particular time. That is the physical law guiding radioactive substance. So from that basis, we are given an amount of 1 gram as initial amount. Find the amount present at any later time. So to do modeling of this, we have to say the y dt. So that is the law guiding it. So we express the proportionality of variation process like that, and we can say the y dt equals to ky. Y dt equals to ky, as k is our proportionality constant. So having done that, we can now rearrange the terms to have the y over y equals to k dt, and the y over y is ln y, and that gives us kt plus the constant of integration, which is c. That is it. So that is it. So the further simplification we can make of this is that we can simply say ln y equals to kt plus c, and our y equals to exponential kt plus c, which is like exponential c multiplied by exponential kt. So this exponential c is a constant on its own, so we can just put it as another greater constant as c star exponential kt. So now we have been able to express the physical law guiding this process, and we have been able to solve the model. This is the solution of the model. So, but this is just a general solution. We need to get a particular solution. Which is that our c star, we need to find it, and our k, we need to find it before we can find a general solution for this. So to do that, we need the initial condition. What are the initial conditions? At time 0, what's the amount of y present at that time? The amount present then was what? 1 gram. Y is equal to 1 gram at time 0. So we substitute that into that. We have 1 is equal to c star exponential k0. So that means what? That implies our c star is equal to 1. Our c star is equal to 1. Therefore, we can now express the expression, the mathematics more generally, as y equals to 1 exponential kt. So that is the general solution for this simple case. So let's look at another. Let's look at another more advanced case. Now, in September 1991, a dead body was found in Italy, preserved in ice. The body was thought to belong to the Stone Age. The ratio of the carbon-14 to carbon-12 in the body is 52.5% of that of a living organism. So now, what the question was asking us is they want to determine when the body actually died. So, but what they find in the body was that there is a radioactive carbon, which is carbon-14. So, and they find the ratio of that carbon-14 in that body to the carbon-12, which is normal carbon in the atmosphere to be 52.5% of that of a living organism. So it means as the body die, the ratio of the carbon 14 to 12 is reducing, and it has been only 52.5%. So that means we are going to take this case as a case of radioactive substance or process as well. There are some information provided there. In the atmosphere of the living organism, the ratio of carbon 14 to 12 is constant. So when an organism dies, its absorption of carbon 14 by breathing and eating terminates. Hence, one can estimate the age of a fossil by comparing the radioactive carbon ratio in the fossil with that in the atmosphere. To do this, we need the half-life of carbon 14, which is 5715 years. So when did the body actually, the person actually died? So to do this, similar to the last one we treated, we shall start from the radioactive decay process, which is the physical law guiding this. That is, now C14 ratio C12 is taken to be Y. Let's take that to be Y. C14 carbon 14 to 12. So, and the rate of change, since it's radioactive, the rate of change of this YTT is proportional to the Y present, which is the physical law guiding radioactive process. So after that, we can now say the YDT, or let's use Y prime to mean the YDT, is equal to what? KY. The YDT is equal to KY. So which K is our constant of variation, proportionality constant. So we can then rearrange this to give us the Y over Y equals to K dt. So if we integrate this, the Y will be giving us KT plus C. KT plus C. Now, you will notice something now. There are two constants, just like before. K is a constant and C is a constant. So we need to find values for these two constants. So, and to find value for them, we need to look at the condition given in the question. The first one was that the ratio of the carbon 14 to 12 in the body is 52.5% of that of living organism. That is, it has reduced from 100% to the to 52.5% of the living organism. So we can infer two things there. That means at t is equal to 0, immediately the body die, or just before the body die, at t is equal to 0. Why the ratio in the body is 100%, which is Y naught, is 100% of the one in the living organism. We don't know the amount actually, but we know it is exactly of the one in the living organism. But after it has died, it has now reduced to, after the time it has died, t that we don't know, the Y has reduced to, Y over Y naught has reduced to 52.5%, which is 0.525. But at the beginning, Y over Y naught is 1. Y over Y naught is 1 at the beginning. So that means it's 100% at that material time. So what do we use to do? So you go back to this equation 1. Now we can substitute the value, or let's express it simpler further. So from equation 1, our Y equals to exponential KT plus C. And as I say, we used to simplify this constant further. It can be exponential C, exponential KT. So, and this exponential C is also a constant, so we can put it as a C prime prime. Then exponential this KT, exponential KT. So, it means, let's use the first condition. At t is equal to 0, t is equal to 0, our Y is Y naught, which is like that of a living organism. So we substitute that. So put 0 here. That means Y equals to C prime exponential 0. And that means what? This is Y naught. So at that time, Y is equal to Y naught. Therefore, our C prime is equal to what? Y naught. Exponential 0 will be 1. So therefore, we can go back to this, our equation. Equation 1 becomes what? So equation 1 becomes equation 1. We can use this now, which is now equation 2. So let's put it, equation 2 becomes what? y equals to y naught exponential kt. Exponential kt. So we need to find k as well too. We have been able to resolve for y. We need to find our y is equal to y naught exponential kt. We need to find our kt, I mean k. So remember this condition. They say that what at half-life of carbon 14 is 5715. That means after 5,715 years, the amount in that body has reduced by half. So what does that actually mean? It means that y over y naught is 0.5 at that time. So initially y over y naught is 1, which is perfect. But at that half-life, it means carbon 14 has reduced by half in 5715 years. Therefore, we can use that condition to find our k. It means at t equals to 5715 years, y over y naught equals to 0.5, which is half-life. Therefore, we can say y over y naught equals to exponential kt. So that is from this equation. So y over y naught is equal to, so 0.5 equals to exponential kt. And that t at that time is what? 5715. So to get k, if you can, we can now say 5715k equals to 0.5, lane 0.5, and k is equal to that lane 0.5 divided by 5715. And what does that give us? It gives us k equals to minus 0.000 1213. So I hope that is clear. Now we can now go back to our equation, which is now what? Y equals to y naught exponential minus 0.0001213 t. So when did the body actually die? You know, when they find it, they find that y over y naught equals to 0.525. Therefore, at the time it died, want to know how long ago it died. So that means y over y naught from this equation is so that means 0.525 equals to exponential minus 0.0001213 t, and minus 0.0001213 t equals to ln 0.525, and our t equals to now 5,312 years. So that means the body died 5,300, about that 5,300 years ago. So I hope that is clear. So let me know in the comment section if you need any further explanation on this. Thank you for listening.